Lesson 5.4, Factors and Multiples. In this lesson, we're going to make lists of factors and multiples. It'll be very helpful to you if you saw lesson 5.2 and 5.3, the two lessons before this one, about factors and divisibility and common factors. Factors and multiples are related. 2 times 3, those are factors of 6, and 6 is our product. A factor times a factor is a product. And the product is a multiple of either factors. 6 is a multiple of 2 and a multiple of 3. We can list multiples. We can write 2 times 1, 2 times 2, 2 times 3, and we write their products. And 2, 4, 6, 8, 10, and 12, these are all multiples of 2. A multiple is a product of a number, like this 2, and a counting number. Here we've listed 3 times 1, 3 times 2, 3 times 3, and the multiples of 3 are these products. 3, 6, 9, 12, 15 are multiples of 3. A multiple is the product of a number, like this 3, and a counting number. So the multiples of 4 are the products of 4 and a counting number, like 4 times 1, 4 times 2, 4 times 3. See? And the multiples of 5 are the products of 5 and a counting number, 5 times 1, 5 times 2, 5 times 3, and so on. Same with the multiples of 6. 6 times 1, 6 times 2, 6 times 3. See? In video 5.2, we learned the rules for divisibility. If a number is divisible by n, some number n, then n is a factor of the number. So remember, a variable, like this letter n, is a letter of the alphabet that takes the place of an unknown amount. When we look for the divisibility and the divisibility rules, we have, is 5 a factor of 12? And it will be divisible by 5 if the last digit of the dividend is a 0 or 5. So no, 12 isn't divisible by 5 because 5 is not a factor of 12, and 12 doesn't end with a 0 or a 5. So we just saw the question, is 5 a factor of 12? Aside from using divisibility rules, like seeing if the 12 ends with a 0 or 5, we can use a list of multiples of 5 to see if 12 is in the list. We write the multiples of 5, 5, 10, 15, 20, 25, and so on. 12 is not in the list. It's not in the list of multiples for 5, so 5 is not a factor of 12. So we can use divisibility rules, and we can make a list of multiples to see if 12 is in the list. Is 7 a factor of 84? We can list the multiples of 7, and we see that it's in the list. So yes, it would be a factor of 84. Or we can divide and use our divisibility rule. We do 84 divided by 7. 7 fits into the 8 one time. We write a 1 above the 8. 7 times 1 is 7, so we subtract that 7, and we get a 1. Then it's the 4's turn to come down. 7 fits into 14 2 times, and 7 times 2 is 14. We subtract and get a 0 remainder. So yes, it is a factor of 84 because 84 is a multiple of 7, and it divides evenly with no remainder. We have 0 left over. We have no remainder. So a multiple is the product of a number and a counting number. It's a product. And the multiples of a number can be found by skip counting by that number. So the multiples of 8, we just skip count by 8. 8, 16, 24, 32, and so on. A common multiple is a multiple of 2 or more numbers. We can list the multiples of 2, 2, 4, 6, 8, 10, 12, 14, and so on. We can list the multiples of 5, 5, 10, 15, 20, 25, 30, and so on. So the common multiples for 2 and 5 are a 10, they both have a 10 in the list, and 20, they both have a 20 in their list. And if we continued listing their multiples, if we kept going, we would find more multiples that they had in common. So what is the lowest multiple that 2 and 5 have in common? We see they have a 10 and a 20 in common. The lowest one would be the 10. 10 is the lowest common multiple for 2 and 5. Mrs. Kim bakes cookies for her bakery every 3 days. Sue Jin works as a cashier at the bakery every 4 days. If Mrs. Kim bakes cookies on November 3rd and Sue Jin works on November 4th, what days will Mrs. Kim make cookies while Sue Jin is working there? So we can mark the days with a letter C for cookie and S for Sue Jin. And the day with both a C and an S will be common multiple days. And we can use multiples of 3 because she bakes every 3 days, and multiples of 4 because she works every 4 days for Sue Jin's work days. And the multiples of 3 because she baked on the 3rd, we would have 3, 6, 9, 12, 15, and so on. And since Sue Jin worked on the 4th and she works every 4 days, we can do multiples of 4, 4, 8, 12, 16, 20, and so on. So let's mark the days that Mrs. Kim baked cookies with our multiples of 3. So we've marked a letter C for cookies on all the multiple 3 days that Mrs. Kim bakes cookies, okay? Now let's mark all the days that are multiples of 4 for when Sue Jin works. We'll mark it with an S. And we look for days that have a C and an S, like November 12th and November 24th. So what days will Mrs. Kim make cookies while Sue Jin is working there? On the 12th and on the 24th. So we can use a blank calendar or make our own calendar to solve a problem like this, but it's very important to notice that not only does Mrs. Kim bake cookies every 3 days, but she also did it on the 3rd. So those matched. That's why we could list the multiples. And Sue Jin works every 4 days, and she worked on the 4th. That's why those multiples worked. If Mrs. Kim baked on the 1st and Sue Jin worked on the 2nd, the number dates wouldn't quite come out the same, and we would have to count, every 3rd day, and the numbers may not match, but we could still do it. This worked because she bakes every 3 days and started on the 3rd, and she works every 4 days and she worked on the 4th, okay? Now we need to write yes or no on these lines. Is the number a factor of 8? Write yes or no. So remember, a factor is a number that is multiplied by another number to get a product. So 8 would be the product. So could we multiply 2 times something to equal 8 as a product? Yes, we can. We can multiply 2 times 4. So that means 4 is also a factor of 8. Can we multiply 3 times something and it will equal 8? No, 3 times 2 is 6, 3 times 3 is 9. It skipped right over the 8, so that's a no. Can we multiply a number times 8 to equal 8? Yes, we can do 1 times 8. 1 times 8 equals 8. 8 is a factor of 8. Can we multiply a counting number times 12 to equal 8? That's not in the 12 times facts, is it? So these are large and This would be a no, this would be a no, and this would be a no, because now we're greater than 8. Now, multiple means many. So multiples of 8 would be many 8s. So is the number a multiple of 8? Is 8 a factor of one of these numbers? That's another way we can ask. 8 times something is not 2, so that's a no. 2 is too small. Can we say 3 is a multiple of 8? Is 8 times something 3? Can you think of a counting number that we can multiply by 8 to equal 3? No. It's too small also, isn't it? And so is the 4. Is 8 a multiple of 8? Is 8 times something equal to that 8? Well, yes. 8 times 1. 8 is not only a factor of 8, it's also a multiple of 8. Is 8 a multiple of 12? Is 8 times something equal to 12? No. What about 16? Is 8 times something equal to 16? Yes, 8 times 2 is equal to 16. What about 24? Is it a multiple of 8? Is 8 times something equal to 24? Yes, 8 times 3 is equal to 24. So just remember that multiple means many. That means a multiple of 8 would be many 8s. So it would be 8, 16, 24, 32, and so on. And a factor is a number that is multiplied to a counting number to get a product of that number. Now it says to write the unknown number. We have to look for a pattern here. It went from 15 to 30 to 45. Do you know what would come next? Do you see what the numbers are doing? This is 15 times 1, 15 times 2, 15 times 3. This would be 15 times 4. We can do a little multiplication on the side and see that 15 times 4 is 60. So that would be a 60. Look at the pattern here. Do you see what it's doing? 50, 100, 150. Do you know what would come next? What are the numbers doing? 50, well, 100, that's 2 50s. That's 2 times 50. 150, that's 3 of them. So we have 1 times 50, 2 times 50, 3 times 50. So what would be 4 times 50? These numbers are skip counting by 50. The next number would be 200. Look at these numbers. Do you know what the unknown number would be? 4, 8, 12, 16. Let's look at the pattern. Well, we have a 4. 4 plus 4 is 8. That's 2 times 4. And we have a 12. That's 3 times 4. Then we have a 16. That's 4 times 4. So it went 1 times 4, 2 times 4, 3 times 4, 4 times 4. That must be 5 times 4. 5 times 4 is equal to 20. These are multiples of 4. It was skip counting by 4. What about here? What do you think the missing number is? Do you see the pattern? These are all skip counting by 7s. These are multiples of 7. 7, 14, 21, 28. We have 1 times 7, 2 times 7, 3 times 7, 4 times 7. And this would be 5 times 7. Do you remember your multiplication facts? 5 times 7 is 35. These were multiples of 15. 15 times 1, 15 times 2, 15 times 3, 15 times 4. These were multiples of 50. 50 times 1, 50 times 2, 50 times 3, 50 times 4. These were multiples of 4, and these were multiples of 7. This one says the answer is 6, 12, 18, 24, 30, 36, 42. Well, if that's the answer, what is a possible question that would fit that answer? What do you think these numbers are? Well, if you said they're multiples of 6, you're right. And we have 1, 2, 3, 4, 5, 6, 7 multiples of 6. The question could be, what are the first 7 multiples of 6? And the answer, 6, 12, 18, 24, 30, 36, 42, would fit that question. What are the first 7 multiples of 6? Because a factor multiplied by another factor is equal to a product, and that product is a multiple of each factor, factors and multiples are related. We have a factor 2 multiplied by a factor 5, and it's equal to the product 10. And this product 10 is a multiple of each of the factors. When we list the multiples of 2, 10 is there. We list the multiples of 5, and 10 is there on the list. And when we list the factors of 10, we see 2 and 5. See? This says to complete the Venn diagram. We first learned about Venn diagrams at the end of 3rd grade, and I'll have a link to the 3rd grade math video 12.8 where we first learned about them. We have 2 circles, and we can see they overlap in the center. This blue circle is for the factors of 36, and this purple one is going to be the first 12 multiples of 3. And the numbers in common, as the goat says, are going to go in the middle. So we can make a list of the factors for 36. We know 1 times 36 is 36, and 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So our factors for 36 are a 1, 2, 3, 4, 6, 9, 12, 18, 36. We can list the multiples of 3 by skip counting by 3s. 3, 6, 9, 12, 15, 18, and so on. Now we can put them into the circles where they belong. And any numbers that they have in common can go in the center. And to keep track, we can circle the ones that we've used or cross them out. So we have a 1 as a factor of 36, but I don't see it on the list of multiples, so 1 would go only on that side. I see 2 as a factor of 36, but I don't see it in the list of multiples, so 2 is only going to go on this side. 3 is in the list of factors for 36 and the multiples of 3, so it's going to go in the center. It's considered both. I don't see a 4 on this list, so 4 is only going to be on the factor side. 6 is going to go in the middle because it's listed for the factors of 36 and the multiples of 3. So is 9. 9 would go into the center. 9 is a factor of 36 and it's a multiple of 3. I see 12 here and I see 12 here, so that would go in the center. I don't see 15 listed as a factor for 36, so that's just going to be considered a multiple of 3. I see 18 as a factor of 36, and it's a multiple of 3, so it's going to go in the center. And I see on the list that 36 is a factor for 36, and it's also on the list of multiples of 3, so that will go into the center because it's on both lists. And we've used all the factors of 36. All we've got are multiples of 3 left. We can put these into this circle on the right side. And the Venn diagram lets us see very easily for the factors of 36 and the first 12 multiples of 3 what they have in common. They have a 3, 6, 9, 12, 18, and 36 in common. Tala paid a total of $16 for 2 items, a book and a pack of pencils. If their prices were multiples of $4, what could the prices have been? Well, the multiples of $4 are $4, $8, $12, $16, $20. But it said she only paid $16. So 20 is too great, we can get rid of the 20. And because there were 2 items, it said she paid for 2 items, they must have been $12 or less to equal $16. So we can't use the $16. If one of the items was $16, that means the other one would have had to been free because she paid a total of $16. So it had to be $12 and something else. 16 would be too great, so we can get rid of the $16. We know both items had a price, so one of them couldn't be free. So it must have been $12 or less to equal $16 together. So our possible prices are $4 plus $12, or it could have been $8 and $8. She could have paid $4 for the pencils and $12 for the book, or $8 for the pencils and $8 for the book. How do we know if 70 is a multiple of 5? Do you remember? We know 70 is a multiple of 5 if it's divisible by 5. And the divisibility rule for 5 is this number would end with a 0 or 5, and 70 does end with a 0. So 70 is a multiple of 5. We can also find if 70 is a multiple of 5 by doing 70 divided by 5. We ask ourselves how many times 5 fits into 70. 5 fits into the 7 one time, and we write that 1 above the 7 we fit it into. 5 times 1 is 5. We subtract and get a 2. It's the zero's turn to come down. We ask ourselves how many times 5 fits into 20. 5 times 4 is 20. And we subtract that 5 times 4 product of 20 and get a 0. And because we have a 0 remainder, we know that 70 is a multiple of 5. We also know that 5 is a factor of 70. 5 times 14 is equal to 70. When we multiply this divisor times the quotient, it'll equal the dividend. So just remember, multiple means many. So the multiples of a number would be many of those numbers. In our next lesson, 5.5, we're going to talk about prime and composite numbers. I hope you stay strong, keep trying, and have a wonderful day. Bye.